Yes, now let us have a revision about the topics that we have seen here. Now, what we have talked about dentist manager program. You can find videos in this channel over here, okay? And what it is just a program that you can enter patient information and you can have records of your patients. AP info, you can prepare again patient forms, can design it as you like for your clinics, and you can enter patient reports and information there and do statistics. Yes, these are free programs, and you can see that there is a revision over here and some other tests that you can find here in English as well as Turkish. Okay, so let us start with our this PowerPoint. I'm going to upload it also to the system. These were the subjects that we have seen before. We have discussed nominal, ordinal, and ratio or interval on SPSS. SPSS program was a program like this. It's opening. It's not a free program. You have to pay for it. I was using the version 25. There is 26 also now. Yes, and here I'm going to open a document, a sub document here. What you have to know here is that only when you see this kind of description, what it means. Okay, I don't expect from you to know how you write it, how you use this program exactly. So you don't. Okay, in future in other courses maybe. If you feel interested, you may improve your knowledge and you will use this program for your analysis. Now, what is our aim in this course? Our aim is just to give you a clue, an idea about what is biostatistics, what are these tests, what they do. When you see R, when you see P, what they mean, okay? When they say confidence interval, for example, what it is. Our aim is all this. So to give you an idea about what's going on in statistical world. And there, as well as the idea, we hope that you will understand, okay, this is not good test, okay? We cannot rely on this because you are studying in health area and you will work in this area. So it's important that you know which tests, which results are trustable and which results you have to ignore. Okay, because you will be alone one day by your own and you will decide your own, you will give your own decisions about your treatments. Here, so this is SPSS, okay? It has two views. This is variable view and this is data view, okay? You have to know that this is SPSS, it has variable view, data view. In the variable view, we have these are, these are here variable names, okay? These are variable names, and here these are labels, okay? And these are scale. So these are defined as scale, okay? So here scale means numbers, okay? We may define it as ordinal or nominal. What was ordinal? If we group them, then we define it as ordinal and it is ordered. Or if we group them, it is not ordered, we define as nominal. Now I'm going to do a descriptive statistics frequencies. So biostatistics is about numbers, percentages, and variables, whether these variables are related with each other, whether there is a significant difference between their means, whether they are dependent, independent, all these are our interests. So here, these frequencies, I click OK. So I have done statistics, okay? So calculating these with hand takes time. Okay, therefore we don't like statisticians, we don't like doing much work at hand. Why? Because maybe that we are tired and we may do some small mistakes, and it will be very, very important. So statistical programs are good for us. They save our time and practical. So what is this? These are just numbers. We have one on these numbers. It's just frequencies that we find it, city code, okay, and it says that there are valid city codes, 50 city codes here, okay. Yes. So this is output. This is an example of an output of an SPSS. I'm going to close it. I don't want to save it. No. Okay. This was an example of SPSS document here. I close it also. No, I don't want to save it. By the way, extension is .sav. Okay. No. Yes, I want to close it and I don't want to save it. Okay. So here. Yes, there are different variables. This was the normal distribution, okay. Mean, mode, median are equal in normal distributions, and if we have normal distributions of here, for example, energy take, calories per take of people here, you see that it shows a normal distribution, and if we have a normal distribution, then we can use parametric tests, okay. So this is not a normal distribution. This is a negatively skewed distribution. This is positively skewed distribution according to here, okay. And this is normal. This is what is not normal that we are mentioning. Okay, so we have seen the parametric and non-parametric tests, and we have seen tests like independent sample t-test, one sample t-test, and one-way ANOVA. Okay, here we have seen that there are parametric tests and non-parametric tests. So if we have normal distributions, then we can use parametric tests. And if we have two independent variables like maybe female, male, okay, two independent variables, then we can use independent sample t-test. Or if we have more than two independent variables, maybe if we are in the health area, we are discussing other sexual people. For example, we can discuss female, male, more than two groups, female, male, lesbians and homosexuals. The others, we can discuss 4 groups and look their health, blood pressures, or some other issues about health. Then we have 4 groups, okay, more than 2 groups. So we can have more than 2 groups, and in that case we have to use one-way ANOVA, okay. So if we have 2 groups, independent sample tests, or we can have tests for 2 different cities, okay, like Yrd and Kyrenia, for example, 2 cities in North Cyprus. Then we can have independent sample t-tests. These are 2 independent cities. Or we can have more than 2 cities, like we can have Kyrenia, we can have Yrd, Nicosia, Famagusta, okay, 4 cities. It depends on us number of groups. So if we have 4, more than 2, then one-way ANOVA. And of course, if we have parametric distributions. If the distributions are not parametric, then we can use here Kruskal-Wallis test, okay. If they are not parametric, we can use Kruskal-Wallis test. Also, if we have 2 dependent variables, like for example, we have measured 100 peoples of let us say in Nicosia, 100 people's COVID-19 test results in February, okay, in 20 February. And then we have a repeated test. We have also COVID-19 test of these 100 people in 1st of March, okay? So it's COVID-19 test in 2 different times, okay? Then this is 2 dependent groups, okay? Group 1, COVID-19 test results, first results and second results are accepted as 2 dependent groups. So this is a test that is ongoing in the world these days, or maybe in biostatistics they are having these days. They will have, in fact, the vaccine test. Vaccine has started nearly. They are being used about 2 or 3 months in all over the world. So they will start such tests like that, vaccine A, for example, and B, okay? So they will give the vaccine A and vaccine B to 100 people, and they will watch them, for example, let us say 3 months, okay? How many people are well after taking vaccine A, and how many people got 19, or maybe not 3 months, after 1 year, okay? How many people are well after 1 year when they take vaccine A, and how many people got COVID-19 positive when they take vaccine B, okay? That kind of test will be delivered because vaccines are new all over the world. So these kind of tests are biostatistic tests, and if they have two different vaccines, okay, vaccine A, vaccine B, then these 2 are independent, okay? 2 independent because they are completely different medicine, okay? Or medicine A, patients who are using medicine A and medicine B, 2 independent. So this kind of tests are delivered via 2 independent groups. And if the distribution is not normal, if they don't show a normal graphic, then we have to use Mann-Whitney test, okay? So the conditions satisfied here are about the parametric test conditions, and here conditions are not satisfied, are the parametric conditions are not satisfied. Yes, if we have pair sample t-tests, mainly the repeated tests, okay? We have done a test in October, and we done the same, we deliver the same test to the same people in 1 month later or 2 months later. This is repeated test, is pair sample t-test, and we have another non-parametric here test, Wilson test. So why I'm saying you these names, okay? Why? Because I just want you to be familiar with these names. You will see them. And one day you will say, okay, teacher told us that there are such tests. Okay, that's all that I want. So one day you will say, okay, Mann-Whitney test, they use this test. This was a test. Well, this means that distribution is not normal. This means that values are different. Okay, they don't show a symmetric graphic. Okay, and if it's not a very powerful test, by the way. You will understand that, okay, I may trust these results or not, but I may not completely trust them, because this parametric test, the test here with this test, okay, parametric tests are more powerful. They because they study with mean, okay, parametric tests are more powerful. These non-parametric tests are less powerful. This gives you a clue. Okay, if you are in the health area and if you have to use that medicine, you will use that. But you will know that you will have some complications, okay? If you are going to decide maybe about your own health or about your family member's health, okay? Then you will understand more about when you have to do some researches from internet about the disease, what it is, and they will give you possible treatments, and these treatments are always with the statistical names and researches, okay, percentages. So you will say, okay, Wilson test, they did this test, not very powerful test, but yes, I may think another treatment, I may go for another treatment which is done with independent sample t-test, pair sample t-test, and showed a significant difference, important difference, and is better for me. This is all that what we want. And these tests here all are done to find whether there are significant differences between means and medians. Median is used for non-parametric tests which are not very powerful, and means are used for parametric tests which are powerful. These are used for that. 1 minute. Yes. Here, let us start with the correlation. Let us have a revision about the correlation topic. Now, what we have told was that if we have a test with ANOVA or t-test, then they compare means or medians. Okay, so medians are used for non-parametric and means are used for parametric, but they all compare. They all look for if there is a significant difference between the means of the measurements. Okay, we have two measurements and we look if there is significant difference between these two measurements. Okay, so now here the correlation is something as we look if there is a relation between, okay, two measurements. We look, this is important. We have a disease, for example, and we see, is it related with this value, okay? Is it related with this measurement of the patient? So if you find that it is related, for example, we have an allergy, okay? We have an allergic reaction in a patient, okay? Then we explore, for example, the patient. We ask questions and we try to find out what is its reason. Maybe that the patient is in smoky areas in the last 2 weeks. That's why that his allergic reaction increased, or what he has eaten, maybe the things that he has eaten in the last 2 weeks, maybe, or in the last 1 week, whatever it is, that his allergic reaction increased. So we have to find what it is related with, okay? So we have to do some tests about that. There are allergic tests, of course, but and here we have to we can search whether a person, for example, is too many eggs, eats eggs each day, and his allergic reactions increases, has spots in the face, or maybe some other things on the body, in the body, okay, some red spots, maybe different allergic reactions can be seen, or some problems in breathing, or other symptoms. Yes, or so we want to find, is there a relation with this? Is it because of that? Or for example, if I drink too much lemonade, I have problem with, how is it? It affects me, okay? And my head tries to spin, so too much lemonade affects me. So it's important to find what it is it's related with. So this is a test that we use for that, this correlation test. And now here, this is an expression here, okay? So what we expect from you as teachers here, we expect you, when you see such a figure, you will say, okay, not much related, okay? That's all, because you see that they are not on a line, okay? That's all that what we want. So here they are distributed, but there tends to be close here, but again you see that they are distributed. They don't exactly are on a line, okay? We want it to be on a line to say that, okay, or close to a line to say that it is related, okay? So in the relation we search for positive and negative relation. It may be 1 or -1. And here this is related, okay? This is related, but they may be more related if these measurements are on this line. They may be more related, okay? So here, for example, there is a negative relation, and there is a curvilinear relation. It goes up here, then down. And what we expect from you is that you know the meanings of these relations, okay? This is strong relation. The more that these dots are on this line, then the more that it is related. So this is weaker, okay? You see that the dots are away. The dots are away. No relationship. So these horizontal lines means no relationship. Even though they are close to each other, we say no relationship, okay? And these are other symbols here. And we see that all these are measurements, by the way, okay? The more the dots you see, that mean that the more patients, the more measurements that we have here, and the more scattered that it is, then the more unrelated it is. Yes, this is a positive negative relation examples here. Okay.